Hello children, so welcome to aimsindia's online classes. Today from physics subject motion topic we are going to continue. So let's start our concept today with a short story children. The story is about the monkey and the zookeeper. The monkey and the zookeeper. So this is introduction children. So there is an interesting monkey down at the zoo. So we have a monkey here in this story. The monkey spends most of its day hanging from the limb of a tree. So the total day, its habit is it is used to hang to the limb of the tree most of the day. The zookeeper feeds the monkey by shooting the bananas from a banana cannon to the monkey in the tree. So here zookeeper is here with the help of cannon, with the help of banana cannon, he used to shoot this banana towards the monkey which is hanging to the limb of the tree. So that is the daily routine of this monkey and this zookeeper. Monkey and this zookeeper. So here, this particular monkey has a habit of dropping from the tree the moment that the banana leaves the muzzle of the cannon. Means this monkey is having a habit. What kind of habit? Means when the banana leaves the muzzle of cannon, means comes out of from this hole, this monkey starts jumping down, falling down. So it is its habit. So the zookeeper is faced with the dilemma of where to aim the banana cannon in order to hit the monkey. Now, if it jumps, as soon as the zookeeper is firing the cannon, it is jumping down. Now this zookeeper he is in dilemma. He is getting doubt where to shoot this banana, to the above the monkey or directly towards the monkey or below the monkey. In what direction if we shoot the banana cannon, the banana will reach the monkey. The zookeeper was in that dilemma. So now the question is, so where should she or he aim the banana cannon so that monkey will catch the banana? So that is our conception that he has to find out. So here we have 4 cases. Throw at the monkey in a gravity-free environment. In a gravity-free environment means if the environment of if the surroundings of monkey and the zookeeper, they are gravity free, means there is no gravity. So then how he has to throw? So if there were no gravity, no gravitational force of the earth, so then what would happen if the banana was shot at the monkey? What path would the banana take? And would it hit the monkey? That is our first question. That is our first question. So here children, so our first part is this one. If there is no gravity, if this banana cannon is shoot directly to the monkey, it will go and hit the monkey. It will go and hit the monkey. So it will go and hit the monkey. Sorry, here this children. So here, as there is no gravity, the monkey is not falling down, because though the monkey wants to come down, there is no gravity. Earth is not attracting the monkey. Though it is leaving the hand, it is flying there only. In the absence of gravity, the monkey, it cannot fall down. That is one reason monkey is staying there, and the cannon, the banana shooted by the cannon will go in a straight line. It is not attracted by the earth. It won't come down. It go directly in the straight line and it will hit the monkey. That is the first case. That is the first case, children. Okay, that is the first case. In the gravity-free environment, the monkey will be there only, and the banana will go in a straight line and reaches the monkey. So he has to shoot the banana in a straight line towards the monkey, where in gravity-free environment. That is one case. So next, when the gravity is on, if there is gravity, so if we throw above the monkey, if we shoot the banana above the monkey, so then what happens? So if there was gravity acting upon both monkey and banana, usual situation, then what would happen if it was shot above the monkey? Okay, this is second case. And third case, when gravity is on, if we throw at fast speed, aiming at monkey, if we throw at fast speed, what happens? That is third case. Or if gravity is on, if we throw at the monkey in the direction of monkey at slow speed, at fast speed, at slow speed. In one case, above the monkey, one case. Second case, fast speed at the monkey. Third case, slow speed at the monkey. Fourth case. So let's see what happens in second, third and fourth cases. So here, second case. So he is throwing where? Aiming above the monkey. So then the gravity is there. It is acting on monkey and it is acting on banana. Because the gravity does not depends on the object. On the monkey and on the banana, it acts in the same manner. As we have aimed above the monkey, so that's why it will loses the target. It won't reaches the monkey. That is second case. So we should not aim above the monkey. Why? Means the gravity is acting on banana and on monkey in the same manner. So that's why we should not aim above the monkey or below the monkey. Okay. Next. This one, third case. So aiming at the monkey with fast speed. So then what happens? It will hit the monkey at close to limb. Here only. It is hitting the monkey here only. Close to the limb. Because we are throwing it with fast speed. If we hit with more speed, it may hit here only. Still somewhat upside. But we have to aim at the monkey. The gravity acting on monkey and banana in the same base. So that's why it will hit the monkey. And what about the path? Path is not straight line. It is like parabola. It is like this curve shape. It is like a curve. So with fast speed, when we aim at monkey, it is touching the monkey. With slow speed, if we aim at the monkey, because we are aiming at slow, the monkey will travel more distance and it will touch the monkey close to the ground, not to the limb, because we are throwing it slow. But this time also we are aiming at monkey. Okay. but it is going in a curved line because of attraction force of earth, and it will hit the monkey. Okay, children. First case, going in straight line, hitting the monkey because there is no gravity. Second case, missing the monkey because we are aiming at higher place than monkey. That's why it is missing. Third case, we are aiming at the monkey with fast speed. It will touch the monkey close to the limb. In fourth case, we are aiming at the monkey with slow speed. It touches the monkey close to the ground. Okay. Okay, children. So by this four, so from these four cases, what we have understood, children, because gravity is acting on the environment, so that's why the zookeeper always aim towards the monkey. The zookeeper always aim towards the monkey. The monkey may come down. If he uses greater speed, it will hit the monkey at a greater height. If he shoots with less speed, it will hit the monkey at lower height. But if he aims the monkey, then only it will hit the monkey, because gravity is acting on banana and the monkey. Banana and the monkey in same ways. That's why the zookeeper always has to aim towards the monkey. And the path of the banana is like a curve, like a parabola, Path of monkey is along a straight line. Path of monkey is along a straight line, but this is a parabola. But time taken by the parabola and time taken by the monkey, both are same. So that's why they will hit each other, because gravity does not depend on type of object. Next. So here, children. Okay. This is one kind of story, children, regarding monkey and zookeeper. So here, so next our main concept is, so motion parameters of a body projected vertically upwards. Okay, projected vertically. Actually, just now what we have learned, it is called projectile motion. Means projected not vertically upwards, projected through some angle. Means body is shooted with some angle with the ground. But instead of like this, if we project it horizontally, okay, children. Now let's learn about this two-dimensional motion. So the motion of an object is called two-dimensional if 2 or 3 coordinates are required to specify the position of the object in space with respect to time. Means if the object changes its position, with respect to time in 2 or more directions, then it will be called as a two-dimensional motion. Means when the object is moving in a plane, not on the line. If it is moving in a plane, means if it is moving in some space, if it is moving in some surface, so then that movement will be called as two-dimensional motion. So here, the billiard ball moving over the billiard table. Here, if you observe, the billiard ball is moving over the billiard table. Billiard ball is moving over the billiard table. It is an example of two-dimensional motion. 1 minute. 1 minute, children. So the billiard ball moving over the billiard table is an example of two-dimensional motion. So if we take coordinate axis here, if this is x-axis, if this is y-axis, the ball is moving in the xy plane. The ball is moving in the xy plane. We need the help of x-axis value and y-axis value to locate its position in between the space. So it's an example of two-dimensional motion. Next. So insect crawling over the floor of a room. Suppose if the insect is crawling in this room, this is x-axis of the room, this is y-axis of the room. To locate the position of insect, we need the help of coordinates of x and y. Coordinates of x and y means the position of the insect changes with respect to these coordinates and changes with respect to time. So it is an example of two-dimensional motion. Or the earth moving around sun. The earth moving around sun. To locate its position, we need the help of some coordinates, and with respect to time, it will change its position. So these are all examples of two-dimensional motions. Two-dimensional motions. But in two-dimensional motions, we have two special cases, like projectile motion, like circular motion. Now, this is an example of circular motion. It's a two-dimensional motion which is happening in circular way. It's a circular motion. So, whereas already we have learned this about this bullet fired from a gun hitting the monkey. We have seen so many examples. This is an example of projectile motion. In two-dimensional motion, so this is an example of projectile motion. This is an example of projectile motion, and the earth moving around the sun is an example of circular motion. So, two types of two-dimensional motions are there. One is projectile motion, another one is circular motion. So, about projectile motion already we have learnt all. So, what is projectile? So, projectile means any body projected into the air at an angle other than 90 degrees with the horizontal near the surface of the earth. If this is the surface of the earth, if this is 90 degrees, any body projected other than 90 degrees, with this angle, with this angle, with this angle, or this angle, these all angles are other than 90 degrees. So that body will be called as a projectile. Means a body thrown from the surface into the air with an angle other than 90 degrees is called a projectile. And the path, if we throw with an angle other than 90 degrees, it follows this path. It moves like a parabola. It depends on what force we are applying. Based on that, this curve will be different, but it will move in the form of a parabola, or this is called trajectory. This curved path is called trajectory. Curved path is called trajectory. So a body which is in flight means which is in air, which is flying in air. A body which is in flight through the atmosphere but is not being propelled by any fuel means a ball thrown upwards into the air. While throwing, initially we have applied some force. After that, no force is applied on that. By itself it is moving. By itself it is moving in the air without any fuel, without being propelled, without being filled by any fuel. It is moving in the atmosphere by its own force with the help of the initial force what we have provided. So this is called as a projectile, and its path is called as a trajectory. Path is called as a trajectory. Here, children. So here a bomb released from an aeroplane in a level flight. If the flight is moving like this, if a bomb is released, it will follow from the plane. From the plane, if you observe, means it is falling vertically downward. But from the ground, if you observe, means it appears like it is falling through a parabola. See here. It appears that it is like this. It is falling like this. So this is pilot view. Straightly falling down is pilot view. This parabola is ground observer view. So we have two views. In the bomb released from an aeroplane from level flight, we have two views. One is a pilot view. For the pilot, it appears that it falls straightly downwards. But for a person who is observing from the ground, it has traveled a parabolic path. Parabolic path. So this is an example of projectile motion. Projectile motion. A bullet fired from a gun. A bullet fired from a gun. After some time, it will fall down. It's a projectile. Arrow. Arrow. Like this arrow. Sorry, not this. This is not arrow. If we release an arrow from a bow, it go up and it will fall down. Like parabola. Like a projectile. A javelin. In Olympic Games, we will be having this event. Javelin throw. Means throwing the stick. The stick is called javelin. So if they throw the stick, it goes straight, it goes straight, it goes straight, then it will fall down. Like a projectile. Like a projectile. So all these are examples of projectiles. So all these are examples of projectiles. Next one. Assumptions of projectile motion. So if any projectile motion is happening, we have to assume that these below statements are true. There is no air resistance due to air, because if two objects are falling down, when air is there, so due to air resistance, one will be, which is lightweight, will be stopped by the air resistance and it will fall to the ground late. The stone will fall to the ground early. But in the vacuum, in the absence of air resistance, both of them will fall to the ground at the same time. So in projectile motion also, we have to assume there is no air resistance. There is no air resistance. And effect of due to curvature of earth is negligible. Due to shape of earth, due to curvature of earth, whatever effect is there happening in the projectile motion, that effect is negligible. Like that we have to assume. So effect due to rotation of earth, negligible. So acceleration due to gravity at all points of trajectory, G, is constant in magnitude and direction. So these assumptions we have to keep in mind. So no air resistance, effect due to curvature, negligible, effect due to rotation, negligible, acceleration due to gravity, G, is constant at all places, both in magnitude and direction. These assumptions we have to keep in mind. Next we have principles of physical independence of motions. So here the motion of projectile is two-dimensional motion. Means if any projectile is there, if there is a projectile at any point, we can resolve its motion into two components, in vertical direction, in horizontal, direction. At any point, its motion can be resolved into two components: horizontal component, vertical component. So, two-dimensional motion can be discussed in two parts: horizontal motion, vertical motion. At any point, here, at any point, it will be having two parts: horizontal part, vertical part. So these two motions takes place independent of each other. So they won't depend on each other. So at any point, horizontal motion is not at all related to vertical motion. So mx, horizontal motion, my, vertical motion, they are not at all related. So they are independent of each other. This is called principle of physical independence of motions. So these two motions are not depending on each other. This is called a principle of physical independence of motions. So the velocity of the particle can be resolved into two mutually perpendicular components: horizontal component, vertical component. So at any point, suppose here at this point, velocity, suppose the velocity is v, it can be divided into two components: vx, vy. Or at this point, if the velocity is v, vx, vy. Or at this point, if the velocity is v, so vx, vy. At any point, it can be dissolved into two components. So the horizontal component remains unchanged throughout the flight, but the force of gravity continuously affects the vertical component. When it is moving like this, when a projectile is moving like this, because in the beginning we have applied horizontal force, but after that, without any fuel, without any force, it is moving by itself. Only it is affected by the gravitational acceleration due to gravitational force. Only it is pulled down by the gravitational force vertically downwards, but in horizontal direction no force will work. So throughout its journey, here, you can take at any point, horizontal component of velocity will be always same, but at all points, vertical velocity of the vertical component of the velocity will be changing due to the value of z. So here, children, so horizontal component remains unchanged throughout the flight, but vertical component is affected continuously by force of gravity. So horizontal motion is uniform motion without any change. Vertical motion is uniformly accelerated or retarded motion. Means while going up, velocity decreases continuously, constantly. While coming down, velocity increases continuously. Velocity decreases means retardation. Velocity increases means acceleration. Means it is retarded uniformly, accelerated uniformly. While going up, velocity decreased uniformly. While coming down, velocity increased uniformly. Because while going up, it is going up, acceleration acting downwards. So that's why velocity decrease. While coming down, it is coming down, acceleration due to gravity also acting downwards. So velocity will increase. So horizontal motion is uniform motion. Vertical motion is uniformly accelerated, uniformly retarded motion. So in projectile motion, we have some types, children. So one is oblique projectile motion, like this. Oblique projectile motion starting from the ground. Horizontal projectile motion dropping from certain height, like dropping a bomb from aeroplane. here hitting a cricket ball from the into the air, or projectile motion on an inclined plane. So standing on, if we are standing on a plane and we are throwing something, so then it's projectile motion on an inclined plane. We have three types of projectile motions. So one is hitting from the ground, oblique projectile motion with some angle, dropping from aeroplane from certain height, horizontal projectile motion, throwing by standing on an inclined plane, projectile motion on an inclined plane. Like this, we have three types of projectile motions. So in our next video, we can learn about them in detail, one by one. Okay, children. So remaining topics we can learn in next video, children. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.